Okay, welcome. Let us solve question 9 from chapter 1 of Classical Mechanics from the book of Goldstein. So the question reads as electromagnetic field is invariant under Gauss transformation of scalar and vector potential given by this, where psi is a arbitrary but differentiable function or a scalar. What effect does the Gauss transformations have on Lagrangian of particle moving in electromagnetic field? Is the motion affected? Okay, so we'll proceed with the question with the given information. So our A, there is vector potential, is changed to vector potential plus some gradient of psi. Alright, so we can write our A prime as A prime vector as A vector plus so we can write our A prime as A vector plus gradient of phi, which is a function of position vector and time, and our phi prime as phi minus 1 by c partial derivative of phi with respect to time. Alright, now in this case, if we have the original case, okay, when my vector potential is or let me write this as straight. Okay, case 1, when I have phi and a bar, then my u becomes q phi minus q by c a bar dot v bar. So this is something one can learn from electromagnetism. Will not start the discussion of electromagnetism over here. Alright, but this comes from electromagnetism and it's a nice derivation. Alright, and now the case when we have phi prime and a prime, then our u prime becomes q phi prime minus q by, oh sorry, there is no c over here. Okay, it's q a prime dot v. Now I'll put the value of phi prime and a prime in this equation, and what I'll get, q phi minus 1 by c partial derivative with respect to t minus q by minus q into a plus 1 by c grad of phi, sorry, phi into c, sorry, it's v over here. Alright, I hope this is clear. Now I will separate the terms such that q phi prime minus q a v, so over here it's a dot product. Alright, so not to get confused, and then we have minus q by c, the partial derivative of t phi minus q by c grad phi dot v. Alright, I hope like it is clear up till now. Then we know what is this. This is nothing but u, so we are left with u minus q by Okay, it's 1 by c d by dt of phi, alright, minus 1 by c. So this is u prime what we are calculating, grad of phi over the position space and into v bar. So if you know how to calculate total derivative of psi, you can relate this term that it is a total derivative of psi. So this becomes u minus q by c d by dt of psi of r bar comma t. Alright, so this is something you will come to know when you actually do some total derivative. And also if you have seen the previous video that is on question 8, you will relate it more how to have the or how to have the total derivative of any function f which is differentiable with respect to t. Alright, so just to give you an highlight, I'm detouring a bit. Alright, so dt with f is 0.1. Okay, instead let me take some general coordinates to give you a better idea. Okay, the value of this would be, so this is nothing but q1 q2 up to qn, and this will give me nothing but k del f by del qk into del qk dot, this is nothing but the generalized velocity which can be related to a normal velocity, alright, plus partial derivative of f with respect to t, which is this term. Okay, now I will this blue circle is related to this, and this yellow circle is related to this term. Okay, and because of these two terms are same in the two expressions, and hence we can put this in the total derivative form. Alright, now I will find the Lagrangian. So for this one, my Lagrangian is t minus u. Okay, for case 2, my Lagrangian is t minus u prime, that is t minus u plus q by c d by dt phi of r bar comma t. Alright, and we are substituting this over here, then our L prime becomes L plus q by c d by dt of phi, which is a function of r bar comma t. Okay, so this is nothing but similar to L prime equals to L plus d by dt of f, which are dependent on generalized coordinates. So if you have not seen the video of question 8, I would highly recommend you to see the question 8's video, and so that you get the clear idea from where I am stating this. So since these two have the similar format, then we can say that the L prime follows Lagrangian equation of motion, right? So now we come, what effect does the Gauss transformation have on Lagrangian of particle moving in the magnetic field? Okay, so we can say that this extra term is added to the Lagrangian. All right, so this is the effect that the Lagrangian has under the Gauss transformation, and is the motion affected. So as I've said in the question 8, you would see why the motion is not affected. So I would highly recommend you to refer question 3, which was uploaded before this video. So with this we can say that motion is unaffected under, we can say that motion is unaffected though L is changed to L prime. So thank you for watching the video. I hope you understand this, and this is just a kind of extension to what we have done in question 8. All right, thank you.